Hello, let's solve this heat engine problem manually. There are a lot of numbers here, but let's look at the numbers only when you need them. The first question is determine the thermal efficiency of the engine. You must recall that thermal efficiency is nothing but the desired, which is W dot net, divided by what is required, Q dot in or Q dot H in this case we call it. And look, both the numbers of supply. 200 kilowatt is the power produced. They have to be in the same unit. And what is the required input? It is 400 kilowatts. So it's really a simple problem. So efficiency is 0.5 or 50%. Well, what is the next question? The rate of fuel consumption in kg per hour. Well, so question A has been solved, plus 2B. That seems a little bit tricky, but look, what the heating value means that 45 million joule is released when 1 kg of fuel burns. How much do we need? We need to supply this is the hot reservoir. Here we need to supply 400 kilowatt of heat through fuel. So how much do we need? So the fuel consumption rate will be, suppose we call it m dot fuel, would be how much? If I divide 400 by 45,000, I'll get kg per second. So my answer will be really, if you think about it, 3600 second, and then 400 kilowatt is what we need, and we supply 45,000 kilojoule for every kg we burn. So if you look at the unit, 3600 is what? Second, so many second per hour. What is 400? Kilowatt is what? Kilojoule per second. And what is 45,000? Kilojoule per kg. So as you can see, what we get is second get cancelled. So we get kg per hour as our unit, what is wanted. If we solve this, it is simply, I believe you're going to get it to be, how much it is. Let me just quickly check. Okay, so I used a calculator. It turns out to be 32 kg per hour. Okay, what is the next problem? The next problem is that find the minimum possible fuel consumption rate for the same output. Well, for this, think about it. The minimum possible fuel consumption will happen when the engine operates like a Carnot cycle. So what is the Carnot efficiency for this? They have supplied us the hot temperature and the cold temperature. We know the formula for Carnot efficiency is nothing but thermal efficiency Carnot, 1 minus Tc over Th, which is 1 minus 300 over 2000, which turns out to be 0.85 in this case, or 85%. So therefore, we know how much heat we need for the Carnot engine for the same output. So we want to know the Q dot H for Carnot would be what? Would be W dot net that is producing, which is the same 200 divided by 0.85, which is turns out to be 235.3. So now we can again go back and try to find out the fuel consumption rate would be what? 3600, and the amount of heat that we need every second, so many kilojoule per second or kilowatt, divided by 45,000. And that turns out to be something like 18.82 kg per hour. So therefore, we found the minimum amount of fuel that we need to produce the same amount of output, versus in actual engine, which is only 50% efficiency, we need a lot more. We need 32 kg per hour. So I hope the answers make sense, and we'll go ahead and try to verify. Even though it's such a simple problem, we'll make a habit of verifying every solution using test step wherever possible.